Hi everybody, it's Miss Austin. I'm going to be doing the lesson 13 practice problems. Number 1, it says the polynomial function b of x equals x to the third minus 21x plus 20 has a known factor of x minus 4. Sorry, zooming that in. Rewrite b of x as a product of linear. Well, this is a third degree, so it's going to have 3 factors. I know one of them, x minus 4. So how am I going to get the other 2? I'm going to work backwards. When I know the factors, I multiply to get standard form. When I know standard form, I divide to go back to factored. So I don't really think there's well, I guess there kind of is. So I'm going to do the box method. Okay, and I know that x times something makes this first term. I also noticed something strange. See how it goes x to the third and then it's straight to x to the first? There's no x squareds, which there just happen to be 0 of them. But I need to think about that when I'm working backwards. So I'm just going to hold that in so I can consider it, right? There were 0 x squareds. That's why they didn't write it in. Okay, so now what times x makes x to the third? X squared. X squared times negative 4 makes negative 4x squared. Now these two combine to make this. Well, negative 4x squared plus what makes 0x squared? 4x squared. Now I work backwards. X times what makes 4x squared? 4x. 4x times negative 4 makes negative 16x. Do a different color here. These two make negative 21. So negative 16 and what make negative 21? Negative 5x. Work backwards. X times what makes negative 5x? Negative 5. And here's how I always make sure that I've done it correctly. These two better make the constant right here. Negative 5 times negative 4, 20. That's what it should have been. So now I know this right here is correct. That means x minus 4 times that makes this third degree. But that's still x to the second power. I need them written as linear. Well, we know how to break this down into a pair of linears. I do my Timba puzzle. What two numbers multiply to negative 5 but add to 4? 5 and 1, negative 1. Now those two numbers go in my parentheses. So the final answer is you were given this factor, you divided with that factor, got this, and broke that down to find these two, x plus 5 times x minus 1. I should probably write b of x, but all right. Okay, you know what's so weird? It doesn't show when I printed this out, it doesn't show the mistake. Let's hope Miss Austin can find this real quick in her book. It says, let the function p be defined by p of x. I'm going to have to rewrite it out. Where x plus 9 is a factor. To rewrite the function as the product of two factors, long division was used. So I'm just, in your book, this was already written. For some reason, this is not showing up on mine. Do. You could fast forward the video because Miss Austin has to write all this down. I'm just copying what was in the book. I'm not claiming this is correct because they say that there's an error, but for some reason, the PDF version does not print the problem. So this problem that I'm writing is in your book. All right. We're back if you took a commercial break. Here we go. This is actually printed in your book. It says long division was used. They took x plus 9, boom, and divided it into this third degree polynomial, and they got this. It says, how can we tell, It also said, before I even read this sentence, excuse me, an error was made. How can we tell by looking at the remainder that an error was made? Well, the fact that they said x plus 9 is a factor. If something is a factor, it means it goes into it evenly with no remainder. So there should not be a remainder. The remainder should be 0 because they told me x plus 9 was a factor. That's what they wanted you to know. If somebody tells you something is a factor, if you do division, you better get 0. If you're doing the box, how do you, if they told me x minus 4 is a factor, how do I know if I'm doing it right? Because at the end, these two better multiply to that. That's how you check when you're doing the box. Okay? And if you wanted to know where the mistake is, it's right here. X times x squared makes x to the third. X squared times 9 makes 9x squared. And then the algorithm for division is that you subtract both of these. They didn't change that to a negative 9. That should not be 16x squared. That's where they went wrong. All right, moving on. This video is going to be long. Oh boy. Number 3. For the polynomial function a of x, we know x minus 5 is a factor. Select all the other linear factors. This one's a bit of a doozy. It's 4th degree. There's 1, 2, 3, 4. We really haven't done many of these in class. I know x minus 5 is 1. So I'm going to go ahead and do my box division and get this down to something more manageable, right? I know x times something makes this first one. So that's x to the third, negative 5x to the third. These two make negative 2x to the third. So that'd be 3x to the third. So now this is 3x squared. That'd make negative 15x squared. These two have to make negative 21x. I'm just using the same color now. Negative 6x. So that's negative 6x squared. Negative 6x times x is negative 6x squared. That would be positive 30x, right? These two, need another row or column, have to make this. So 30 and what would make 22? I need this to be negative 8x. So it'd be negative 8. And then if I'm right, this times this better make that last one. Yay! Okay, now we're left with an x to the third. Unfortunately, you can't come over here and do a Timba puzzle on x to the third. The only kind of polynomial you can do this Timba puzzle on is an x to the squared. So this has to be broken down again. How do I know which one of these is a factor? I don't. So I'm just going to start with a, and I'm going to hope a is one of them. So I'm going to take x plus 1, excuse me, and I'm going to divide it into this. Okay, so now I'm trying to figure out what makes x to the third. I'm trying to make this guy. X times what makes x to the third? X squared. Now I've got 1x squared. These two have to make 3x squared. So this is 2x squared. So that's 2x. That's 2x. These two have to make negative 6x. So that's negative 8x. So this is negative 8. And then this better work. Negative 8 times 1 makes negative 8. Yay. Yay. Now, this was a factor. How do I know? Because when I did the box, it all worked out perfectly. I got x plus 1 times this, and it made all of this into this standard form polynomial. So I now know x plus 1 was one of the factors. I got lucky. Now, I can use my Timba puzzle to break this one down because there's two more. This is a second degree. There's two more hidden in here. What two numbers multiply to negative 8 but add to 2? 4 and 2, negative 2. So the next ones are x plus 4, which is E, and x minus 2, which is D. All right, number 4. Match the polynomial function with its constant term. You don't have to multiply the whole polynomial all, out to find the constant. You can just multiply the numbers together. So on this one, there's -2 times -3 times 7. That's 6. 6 times 7 is 42. So this one is 42. This one's A. All right, this one I've got 2 times -3 times 7. That's -6 times 7, which is -42. So this one's B. Now this one, you see how you got the 1/2 out here? You have to multiply that in. So you have -2 times -3 times 7, which was the same as this one, 42, but times half. Half of 42 is 21. So this one is C. This one is the same as A again. -2 times -3 times 7 is 42, but I have to multiply that by 5. That would get distributed through. What's 42 times 5? 210. So this one is D, and then we better just make sure. This one would be 42 times -5, which is -210, which is E. Number 5, what are the solutions to the equation? When does this, which is a quadratic, run into a constant? Okay, so in order to do this, I'm going to multiply this into standard form. You could use a box, you could do it in your head. X minus 2 times x minus 4. X squared minus 2x minus 4x plus 8. So this is x squared minus 6x plus 8. When does that run into 8? The only way to solve a quadratic that has x squared and x is to move everything over to one side and refactor it. We couldn't get the 8 in there the way this was written. So now I'm going to minus 8 minus 8. So I have x squared minus 6x. That makes 0. Well, now, do we know what two numbers would turn this equation into 0? I can if I factor it. I do my little puzzle. What two numbers multiply to 0 but add to -6? 0 and -6. So this is x plus 0 and x minus 6. Sorry, that was my reminder to do my food for the food drive. Now, when it's 0, you can just write it with just x. But anyways, so now I know that these two run into each other at whatever the solutions to this equation, right? What will turn this into a 0? 0. What will turn this into a 0? 6. So these two run into each other at 0 something and 6 something. Don't think those together make the solution. These are just the x coordinates, right? Think of a graph. A graph has an x and a y. So now to figure out the y, hopefully you would recognize here that on this side, the only y availability is 8, because that's what this one is no matter what. But if you don't get that and you want to see a different way, if you just take this number and plug it in here and here. So I'll write the equation right here. If I put a 0 here and here, that would make -2 times -4, which is 8. And then I do it again, but I put a 6 in. Let me do that down. I'll do it up here. If I do 6 minus 2, I get 4 times. If I do 6 minus 4, I get 2. What's 4 times 2? 8. If you were to go to Desmos right now and type that in, and then that in the next line, they would run into each other at 0, 8 and 6, 8. Okay. Number 6. End behavior. It says the graph of a polynomial function f is shown. Which statement is true about the end behavior? Well, it's getting bigger and bigger in the positive direction over here, and it's getting bigger and bigger in the negative direction over here. So how do we say this in math? As x gets bigger and bigger, I'm talking about x right now. As I am getting bigger and bigger in this positive direction on the x-axis, what is happening to my graph? It is getting bigger and bigger in the positive direction. Now, when I get bigger and bigger this way in the negative direction on the x-axis, what's happening to my graph? it is getting bigger and bigger in the negative. So now I got to find which one of these says that. Letter A, as x gets larger and larger in either the positive or the negative, so it's saying no matter which way I go, f of x, which means the graph, gets larger and larger in the positive. Is that true? No. Over here it's getting positive, but over here it's down here in the negatives. No. Letter B, as x gets larger and larger in the positive, the graph gets larger and larger in the positive. Yes. As x gets larger and larger in the negative, the graph gets larger and larger in the negative. This is my match. I don't need to read the rest. All right, last one. The polynomial function p of x equals x to the third plus 3x squared minus 6x plus 8 has a known factor of x plus 4. Rewrite it as a product of linear. It's an x to the third. 1, 2, 3. I know one of them. So I'm going to work backwards. Here's that problem again. I know x to the third goes right here. X times what makes x to the third? X squared. That would make 4x squared. This plus this has to make 3x squared. 4x and what make, 4x squared and what x squared make 3x squared? Negative 1x squared. X times what makes that? Negative 1x. That would make negative 4x. This and this have to make negative 6x. I don't know if it helps to show you those. Now these two have to combine to a negative 6. So that's going to be a negative 2. So that's negative 2. Now negative 2 times negative 4 makes, ding, 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 negative 8. I did it correctly. Now, the whole reason I did this is because now I know that x plus 4 times this makes this third degree. But I know how to break that down into two linears with my Timba puzzle. What two numbers multiply to negative 2 but add to negative 1? 2 and 1. I need my 2 to be negative. So this is x minus 2, x plus 1. Now I'm going to do a rough sketch. My dog is crying. So my intercepts are at negative 4. 1, 2, 3, 4. Positive 2. And negative 1. It is a third degree with a positive leading coefficient. That means it's going up over here and down over here. The y-intercept is negative 8. Just ballpark it. So this is going to, and there's 3 factors. They each occur one time, right? We don't write it, but that's to the first degree, first degree, first degree. So they all are just going through once. Once, once, once. That, I don't really know if that's how far up it goes. This could come further down and then come back up, right? That's why this is called a sketch. This here is called a relative max. This down here is called a relative min, okay? But as long as you have the end behavior correctly, the intercepts correct, and your vertical or your y-intercept, you're good to go. I hope that helped. I'll see you soon.